Okay, we are live and welcome to the session on hybrid AI in the European Big Data Value Forum 21. So this session is called How Knowledge Models Are Essential for Trustworthy AI. My name is Freek Bomhoff. I am a consultant at TNO, which is the Dutch research organization for applied research. And we have a number of interesting speakers in this session, and I will briefly introduce them to you. The first is one of my colleagues, Tommaso Manucci. Tommaso, he is working as a researcher on applications of autonomous systems and how to use machine learning in these autonomous systems. He has primarily worked with unmanned aerial systems, but he's now working on ground-based systems, as you will see in his presentation. We then have Professor Paolo Giudici of the University of Pavia, who is a professor of statistics and risk management at the universities there. And he is very much involved in various Horizon projects, also member of various editorial boards and steering committees. So you will find his name everywhere as long as you are looking into the financial sector and the usage of data intensive systems there, primarily related to statistics and risk management. And lastly, we have Christian Müller of DFKI, the German research organization on artificial intelligence. He is the head of the Competence Center of Autonomous Driving at DFKI. And there he is focusing on AI technology as a part of sensor-based environment perception and also trajectory planning, and also in general, how artificial drivers, how autonomous vehicles are behaving on the road. Dr. Müller has not yet joined us, so he is probably delayed a little bit, but he will join in later in this session, and he's conveniently scheduled towards the end of the session. This session is scheduled to last until 5:30. So that means every speaker has roughly 30 minutes, and we expect that the presentation itself will be somewhere between 15-25 minutes, leaving room for interactions from the audience. You can use the chat window to ask your questions. And then I will act as a moderator and pick the questions and forward them to the speakers. And at the end of the session, when there is time left, we can have also a more general interaction with all of the speakers and to look back at what we've learned on this rather, well, some say old-fashioned way of doing AI. Everybody knows that AI has reached far and very interesting results in the recently because of the abundance of data that is available and with the usage of recent developments like deep learning. But many AI researchers have come to the conclusion that there is a limit, an upper limit to what you can reach with a data-only approach. And that is why many people have started to shift their attention to also what is called the good old-fashioned AI, based on knowledge rules, knowledge models, and how to effectively integrate them with data-driven approaches. And we believe that this hybrid AI, both knowledge-driven and data-driven, hybrid AI is really one of the fundamental technologies that is needed if you want to reach trustworthy AI, as we like to reach within the European Union, and also complying with the proposed AI regulation. So we hope to give you some insight into our into some recent developments and some plans that we are about to carry out that all involve hybrid AI and that are all aimed at reaching trustworthy AI systems. So without much further ado, I would like to invite Dr. Tommaso Manucci to the floor and ask him to share with us what they have done with hybrid AI in the context of autonomous systems. Tommaso, the floor is yours. You can share your screen.
Thank you very much, Freek. I will indeed share the screen. As soon as I can do that, I should be able to see my screen at the moment. Frey, can you confirm?
Yeah.
Okay. Well, first of all, let's go a little bit back. First of all, welcome everyone. I'm very pleased of being here and thank you for the introduction. Indeed, my topic today would be on trustworthy robotic search missions via hybrid AI planning. So trustworthy is right in the title. And I would like to show you how hybrid AI can be a very powerful tool to gain trustworthiness in autonomous systems, whether they are robotic or not. First, I would like to just mention what here at the TNO we consider some of the most important challenges for AI in, let's say, moving from current AI application to future AI application. And we see actually 4 different, let's say, dimensions. We have a dimension of purpose, so moving from single purpose to multiple purpose AI. We have the dimension of environment, moving from a more controlled, organized environment to a more open environment, moving from, let's say, low risk applications to high risk applications, and finally moving from, let's say, standalone AI to collaborative AI, which might even involve humans. And looking about the challenge of moving to a more open environment, this is where our the project of which we talk today is situated, Project Snow. And this Snow is let's say, a shortening of the sentence safe autonomous systems in an open world. And specifically, the one challenge that we're trying to tackle with this project is how to reduce the number of operator interventions, so the number of time that humans have to actually intervene during autonomous missions. We know that for remotely controlled systems, this complexity, increasing the complexity of the environment, there would be an increase in interventions. What we're trying to do with Snow, as you can see from let me get the pointer actually, as you can see from this graphic, we want to reduce the number of interventions, and we also want to reduce the increase in interventions with the increase in complexity of the environment for autonomous systems. How we do that? Well, we have an approach in mind, of course, which at its core has both hybrid AI and awareness, making the system as aware as we can do it. Both aware of its situation, so achieving situation awareness, recognizing new objects, for example. User awareness, so the system should be aware of what its goal should be, what the preferences for its course of actions are, but also self-awareness, meaning with that, having a system that is aware of what its competencies are and what task it can provide. And hybrid AI has a fundamental role in this, in, again, merging data-driven approaches and algorithms with symbolic reasoning and optimization in promoting these 3 levels of awareness, and we will see at least one of them, how we will promote that. Concluding on the project, one of the interesting points is that we don't want to just develop algorithms, but we want to actually integrate these different levels of awareness into one system. And that's why we integrated different contributions in these different levels of awareness into one platform, which is the robot Spot from Boston Dynamics, which you saw in the first slide. Now that I presented the project a little bit, what is actually the role of hybrid AI within the project in Snow? The idea is that, as in many systems, we have different functional blocks, different functional steps, even if you want. We go from goal management to self-assessment, planning, execution, situation assessment. And these are all functional blocks that are developed almost in isolation, I would say, and they have their own subsymbolic models that are dedicated to the goal of each block. However, we also have a central knowledge base, which is actually connected to each of these functional blocks, and which has two roles. First of all, it acts as a repository of knowledge and information and makes it so that every functional block essentially speaks the same language. It has the same understanding of the environment and of the mission, and also acts as a repository of new information. So every time that each of these blocks decides to put new information into the knowledge base, this becomes accessible to all other functionalities. This has advantages because it essentially makes it sure that every function is aligned constantly during the life of the robot. And if the knowledge base is also user interpretable, makes it so that the behavior of the robot is also interpretable to a human external observer. Of course, this also requires that the development of these blocks cannot be entirely in isolation, but should be somewhat concurrent because it creates interdependencies. But this is more, I would say, a good push to work that way rather than a disadvantage, I should say. Having talked about the role of hybrid AI, I would like to tell you a little bit about the use case that we have been pursuing in the project as a way to test the capabilities of the system. This use case is a search and assess victim mission done in principle with the Spot robot that I already introduced. The storyline goes a little bit as follows. The idea is that there is a villa from which we received a call because smoke is coming out of this villa, and we suspect that people might be inside this building. A fire brigade is dispatched, and one member of this team is sent into the building, but it does not come out. So the suspicion is that there might be a safety issue, for example, because of gases. Therefore, the idea is instead of sending say, more members of the fire brigade, the idea is to dispatch Spot, which has a specific mission. It should locate the different victims, that is basically the firemen and the family members in the villa, and assess how responsive they are. So which might be an indication that they might need treatment or that we might execute rapidly. In the rest of the presentation, what I will do, essentially, I will show you how within this use case or within this operational context, hybrid AI can be used during goal management, planning, and execution to ensure a more trustworthy system, or at least I will try to convince you of that. Speaking about goal management, as we said before, the goal of Spot is to find people and assess their mental response. One way that we can actually manage our goal using knowledge is by retrieving information on where people are more likely to be placed within the villa and within the rooms of the villa. So assuming I have different people that I'm expecting, Alice, Bob, Cindy, and I believe Dave, knowing where people are more likely to be present at a different time of the day can allow us to create probability distribution for the location of each individual. Of course, this distribution is updated during the search of the mission because people might be found or room might be cleared. But what's important is that if we manage to keep a link between the knowledge of the location of people and these distributions, we might actually be able to leverage logic statements that we will not be able to do if we're only looking at the sub-symbolic let's say representation in terms of probability. Let's say, for example, that we have been in the bedroom where we know that Alice and Bob might be here and nobody else, and we found somebody, but we don't know, we are unable to distinguish whether it's Bob or Alice. We know that Bob could also be in the kitchen, and if for now we go to the kitchen and we do find Bob there, we recognize that Bob is there, then our knowledge can tell us that there is a high likely chance that the person that we found in the bedroom is Alice. And this is a type of inference which will be more complex to handle if we were only looking at the sub-symbolic representation of this information. Now, enough for goal management. Let's look with the time that we have left to the planning and execution. The planner that we devised to handle this challenge, this mission, is actually a layer planner with 3 different layers. Each of these layer essentially solves the problem at a different level of abstraction. So going from the most abstract mission plan to the very concrete, almost execution level behavior service. What the mission planner does, it solves at least the start of the mission as a series of tasks, which are, as I said already, quite abstract. Each of these tasks is then provided to a task planner, which decomposes the task into individual behaviors and provides it to a behavior server service. And the behavior services, what they do they actually interact with the drivers, that is basically with the actuation of the robot Spot. And of course, we have, from all of these interactions, we can have feedback. What's important here, and you will see in the next slides, is that all of these layers are connected to knowledge. So we don't have, let's say, an individual connection here and there, but there is a consistency in how these layers are connected to our knowledge base. The mission planner is maybe the one that has the, let's say, most concrete connection, because we actually use the information and the models in our knowledge base to generate the model used for planning. I'll just explain myself. In our knowledge base, we actually introduce in the form of templates different models used for planning. For example, we can introduce action templates. So essentially describing in understandable terms what the different capabilities of the robot Spot are. For example, we might have the capability of searching in a room, and this might, we actually indicate that it's connected to the concept of room and the concept of coverage and so on. Of course, in the knowledge base, we also have information about the instances of model and entities. So for example, the instances of the actual rooms that are present in the villa. So if we combine these two things, we can actually generate all the actions that Spot can actually take and all the behavior Spot can actually assume during our mission in a very flexible way. Of course, those, let's say, elements that are a bit too complex to be incorporated in our knowledge base can still be retained, adding to the knowledge base pointers to auxiliary Python code. In this way, literally all that we need to know will be inserted and present in the knowledge base, including those pointers. What we actually generate is a partial observable or non-partial observable Markov decision process, which, if you don't know, it's a very common, very widespread framework for planning, which we can later solve with MCTS-like approach, where MCTS stands for Monte Carlo research. What is very good is that if we do use this knowledge-based representation of our model, we have a lot of freedom because we can control our planning and we are, let's say, on top of our planning, even as the environment changes, for example, because new instances will be added, for example, new rooms, if new rooms are discovered in this villa building. We can also forbid or modify or even allow or introduce actions by modifying essentially the way that these are described in our knowledge base, so the way that we essentially define even at runtime. One way that, for example, we do use this flexibility is by adding contextualization, which means essentially allowing or forbidding actions depending on the environmental conditions the Spot is finding during the mission itself. So consider, for example, having to look into a room to see if there are any people. What we will do is checking the environmental condition in terms of visibility. So for example, is there enough light? Is there smoke in the room? And if the visibility is low, then we know that using a camera to look into the room is probably not a good idea. So we can actually forbid this action. Now, enough for the mission planning. If we look at task planning, which has the role, again, of taking the task and decomposing it into smaller behaviors. We already mentioned how at the mission level, these tasks are defined in quite an abstract way. What task planning does is decompose the task into behaviors, as we already mentioned. But in order to do this, it requires some more specific information. I'll give an example. One of the tasks that we might have is to assess if victims in a room are, let's say, responsive or not. One thing that we can do is check in the knowledge base if victims are still present in that room. Because, of course, during planning and after planning, the world might have changed in the meantime. So it might be that people have moved, for example. So if we can confirm the victims are still present into the room, then we can, for example, prioritize. So this is not a choice made at mission level, it's made at task level. Okay, if there are multiple victims, who should I try to assess first? For example, there might be kids or elderly. Even after having approached victims and identified them, we can have additional steps which might actually write back to the knowledge base, such as confirming identification. So we see how even during, let's say, subsequent planning at task level, we can actually interact with the knowledge base in similar terms what we did during the mission. Finally, going at, let's say, the very last level of planning, basically bordering execution, we have the behavior planning. Now, behavior services are essentially in charge, as I said before, of contacting the drivers which will execute and actuate the actual actions of Spot. You might think that at this level, we might not actually need the interaction with the knowledge base, but we still do for at least one reason. First of all, consider this simple example of exiting via a door. So this is very easy behavior, right? What Spot will do is that it will move in front of the doorway, and then it will move through the doorway. So this is a very simple behavior indeed. Now, the point is that we could have provided the behavior service just with the coordinates of the door. But assume that in the meantime, what happened is that the door was closed. We initially thought that the door was open, but at the start of the behavior and during the execution of the behavior, somebody closed the door. Well, if we had just provided information about the position, Spot will just move and possibly bounce with the door, have a collision, or incur in some other unwanted failure. By connecting the behavior server with the knowledge base, we can add additional checks, such as, for example, checking if the door that we requested Spot to move through is still open or not. So what we do, what we have as a result of bringing hybrid AI and hybrid planning to this level is that behaviors are constantly updated with the latest information. And this is immensely important when dealing with open worlds. Now, this concludes essentially my presentation, but I would like to just summarize what I just presented. We have come to the conclusion that hybrid AI and essentially the combination of data-driven, or in any case, sub-symbolic planning and sub-symbolic goal management and execution with symbolic reasoning and optimization is very beneficial for robotic applications and for autonomous systems in general. Because hybrid AI can be used to increase trustworthiness, because we're dealing with a updated, always connected repository of knowledge information. We can apply the information from the knowledge base transversally, vertically along the planning. So we don't have to consider it only at a specific level, but we can do it at multiple levels. And first of all, I didn't mention this too much, but of course, you can imagine that this level of coordination that we can achieve in planning can also be achieved between the different functionalities, different level of awareness. So we can literally use knowledge base also as a way to connect different functionalities of the system. Well, this really is my conclusion. I want to thank you very much. I think we have some time to take questions, but in case you had questions that were not eventually answered or that you come up later, you can reach me and ask the projects know at the email that you see here in the slide.
Yeah, thank you. Thank you very much, Tommaso. That is, it's always an impressive piece of work. I already knew this project for quite some time, but it's always impressive. What I found equally impressive is that the inclusion of explicit world knowledge comes so naturally in all of the examples that you give. So I was wondering, have there been topics where there was actually a choice between using explicit world models or using a more data-driven approach to solve the same problem? Because as you present it right now, it almost seems always things making to look easy. That is also a way of being brilliant, of course. If it seems easy, it is probably quite complicated, but it seems so straightforward. So have there been struggles where to put in world knowledge or where to put in data-driven knowledge?
Well, first of all, thank you. Indeed, we are very happy of the current results of the project. Trying to answer your question, I have one example in my mind. There might have been more, I would say. But I was responsible for the planning and partially for the goal management of the project. So that's why also the examples and the topics that I mentioned are the ones that I presented. One element is that what I just mentioned in this slide that I'm currently sharing again was not initially done in the first year of the project. In the first year of the project, we did not have a link between individuals in the villa and the distributions in the villa itself. So we only had distribution of generic people in the villa, which was essentially handled entirely in a sub-symbolic way. We were still happy with the result, but of course, this also gave us some limitations because assume that we are very much interested in finding, for example, Cindy, which is the kid in this simplified example. Well, if you have lost the link, the connection between the individual and the sub-symbolic representation, right, of generic people in the villa, of course, you basically lost information, so you won't really be able to direct a search. Whereas in this year, because SNOW is a multi-year program, we would technically be able to do such a connection. So indeed, some things might appear naturally, but it has a lot to do with harmonizing the different functional blocks that I mentioned. So the more these blocks are developed in isolation, the more you might have a tendency of developing less hybrid, but developing strictly in a strict connection with the other functionalities really enables to, in the end, to have, I would say, augmented capabilities. But at least this is the let's say, the gamble that we are looking into for SNOW.
Okay, that is a very nice and intriguing conclusion that you reached there, that when you are looking in isolated modules, it is usually, well, one approach is probably the one that you follow, but once the system becomes more complex with more interactions, the opportunities to actually deploy hybrid AI are also much bigger. And I think that is a very important conclusion as well, because the most complex systems are also the ones that we think have the highest requirements of being trustworthy. So I think this is a very positive conclusion. The systems that are potentially most hard to make trustworthy are also the ones that can have the highest benefits from using a hybrid approach.
Yes, and I'm not necessarily advocating to always start from, let's say, always putting all the connection already there. Some things happen organically, like it happened for us in SNOW. But indeed, I agree with you. It's the more complex the system, the more hybridization can encourage, basically can help, I should say, in connecting different functionalities, and can also later bring you with a more capable system.
Yeah. Okay, that's very good to see. Very interesting as well. I do not see questions that have been formulated in the chat window on the stage. So you have left your email address so people can reach out to you if they have some question. And I think then now it is time to move on to the second speaker in this session. Thank you, Tommaso. And then I would now like to welcome to the stage, the virtual stage, Professor Paolo Giudici, who is also a member of the BDVA. That is where we know each other from, and we also know each other from preparing a wonderful project proposal for a Horizon call. And you will present to us what ideas have been developed in this Horizon proposal in order to address challenges with trustworthy AI using hybrid AI.
Yes, indeed. Thank you, Frick. Do you see my screen?
Yeah.
Good. So, well, thank you for for inviting me to this session. And indeed, I would start from where Tommaso left us. That is the idea that complex systems are more predictive, but they do need more hybridization because they are less explainable and potentially less trustworthy. This is exactly what we are doing here. from a different viewpoint, but we are essentially, trying to reach the same conclusion. And so, as Frick was saying, we set up a joint application for Horizon Europe, actually, project that we called TIGER. As you can see here, the acronym is quite complex to translate, in fact, but it stands essentially for Trustworthy AI Getting to the Root of the Problem. So the idea is to develop methods and tools to provide ways to measure trustworthiness, and also methods that are hybrid, that through hybrid AI improve by design that trustworthiness. This is essentially the message that is conveyed through a couple of, let's say, template use cases in finance and the automotive sector that can be made, however, general through a certain toolbox. So I made a quick, overview of the project, but let's now go more in depth. So this is our starting point. Essentially, we are talking about data-driven machine learning models, that are the basis of modern AI. We know that machine learning models have a number of issues that should be improved to, let's say, to boost their implementation in practice. Those problems have to do with, for example, data efficiency, the need that, as machine learning heavily depends on training data, there is clearly an issue about data efficiency, not necessarily. It's not just about the number of data, but the number of data compared to the parameterization of the system. So there is clearly an issue of data efficiency there. There is another issue that concerns predictive accuracy, because very often machine learning model well fit and even overfit the data, and variation and outliers in the data, and then predictive accuracy may be endangered because of this reason. So that is the accuracy aspect. Another issue concerns robustness. Often machine learning models can vary quite much in their output, namely in their predictions. Think about the self-driving car, for which the prediction of the state of the world is essential, not to make an action. Often, this prediction very much depend on specific instances, and the verification of extreme scenarios or particular cases that were not in the model beforehand may turn into a very different prediction. So that is the issue of robustness of the machine learning model that should be improved. So far, we talked about data efficiency, accuracy, robustness. Another issue that we mentioned already is explainability or interpretability. As Tommaso described before, often, especially for very complex models, it's difficult to understand what they're doing in, let's say, human understandable terms, not necessarily in terms of causation, but often which is typically not possible with machine learning, but sometimes even correlations are hard to draw because the model is heavily complex and depending on many nonlinear and hidden relationships. So we need explainability, that is, translate the output, maybe with the model agnostic methods, trying to understand what are the most relevant features and what they do. Last but not least, there is the issue of fairness, that is quite often may arise again with machine learning models, often because there is a sample that is the data that's being used is not fully representative of the the strata of population that are concerned, in terms of gender, in terms of age, in terms of race, for example. This aspect is particularly important for, let's say, applications in services such as finance, less in the automotive sector, but it is highly relevant in general. A last aspect is uncertainty, that machine learning models typically are non-parametric. They do not have confidence intervals or test of hypothesis, the things that statisticians are used to play with, to give a certainty statement to the result. We predict this result. Instead of saying we predict that probability that the car crashes is 80%, we say we predict that the probability that it crashes is between 60 and 90%, an interval that reflects model uncertainty. This is often neglected by machine learning models. So, having said what is the state of the art, say, of the weaknesses of machine learning models, but also having said, as Tommaso was saying, that they may be highly accurate and predictive, we would like to cure the problems to make them more acceptable and more applicable, especially in the European framework, which is particularly concerned with the idea of an AI that is trustworthy and reliable. So within the project that we set up, we combine a number of cures, of solutions. For example, we implement causal relations and game theoretic mechanisms such as Shapley values to provide explainability. We suggest Bayesian modeling as a key tool to have hybrid AI, so hybrid machine learning that combines data-driven relationships with a priori expert knowledge. And we set up, monitor, let's say, a collection of key metrics, key performance, key trustworthiness metrics that can inform us whether the trustworthiness principles are matched by the application, specifically robustness, accuracy, fairness, and explainability. So within the project that we wrote, that whose main ideas I summarized before, there is a consortium composed of universities, research centers, and also industries. Particularly, the coordinator is DFKI from Germany, together with the TNO and the University of Pavia, that is Frick and me, are among the key players. And then we have University of Amsterdam and the Technical University of Eindhoven among the universities. And then we have in the specific companies, such as Valeo for the automotive sector, and Real Rate and Klarna for the financial, or better, financial technology sector, fintech. And last, we have engineering that provides the IT infrastructure that implements what we developed, let's say, in the previous part. So as I said, what we plan to develop, of course, if the project is successful, is let's say, a combined strategy that starts from step one, individuation of trustworthy AI metrics, key performance metrics, in general, they can be applied as test bed for any AI application that involves the use of data, that is KPIs of accuracy, robustness, explainability, and fairness, and data efficiency. So 5. That's the first thing. Second, we develop hybrid AI methods that can improve in terms of the previous 5 principles over classic machine learning methods. Third, we implement the previous 2 into a full IT DevOps implementation, and we do this jointly into key use cases, that is finance and automotive. This is essentially the structure. In fact, the IT infrastructure is called a Boxology framework. So what are the main results that we believe will be reached? As I said a number of times, a way to measure trustworthiness, which you can also frame as a way to measure ethics of AI, no? Because we often talk about the ethicality of AI. That is, there are a number of papers, publications, and discussions on that, but not so much in terms of measuring the ethics of the ethicality of AI. So that is what we provide. And then we contribute to the 2 specific use cases, particularly in the automotive sector, in which the idea is to predict the behavior of the surrounding environment, no? The environment that surrounds a self-driving car. You should understand not only what the other cars are doing, but what pedestrians, bicycles, scooters, whatever you want, are doing. And this is a very challenging task, highly multidimensional. Whereas in the field of finance, we have certainly much less data, but the challenge there is that the sector is highly regulated. So in finance, the application we will deal with is credit scoring, you know, what is used to assign a credit, you know, what a bank or a fintech or whatever financial service calculates before deciding whether to give a credit or not, and before deciding what type of interest rate to price on that loan. And clearly, the data that is used is about the characteristics of the applicant. No? If the applicant is an individual, it would be personal characteristics, but also transactions in the bank account and so on. If the applicant is a company, you also want to look at financial performance, balance sheets, and so on. In both cases, the data is not as much as in the automotive, less multidimensional, but the sector is highly regulated because any bank or fintech is supervised by European Central Bank and by authorities, financial authorities. So any model that is in place should be validated by those authorities. So for the time being, it's very difficult for a machine learning model to be validated by authorities because they are black box. So here they need to develop explainability is key for the very existence of the AI application. In fact, without the reaching of trustworthiness, it is almost impossible to put through financial services based on AI. And as I said, there is a toolkit that implement all of this in an open source code repository. So that is the idea. Again, on the use cases, in fact, this is something I said already. For a highly automatic driving, the case that I mentioned, the automotive sector, we are still in some kind of disillusion. No? Seems that we are at least 30 years away before the implementation of this, especially on local streets, no? Not on highways, where it's somehow easier to do this. There is a research currently on the perception of the behaviors, but the challenge is to create reliable predictions of human behavior. That is very difficult to do because it is highly interactive. It's a game theoretic thing. So these are huge. The main challenges here are data efficiency, robustness, and accuracy or generalizability. And Tiger would fill this gap building models that include contextual information, expert knowledge, and thereby provide through hybrid AI a better solution. In the financial case, as I said before, data is lower dimensional, but the models must be validated by the authorities. So here the challenge is not much about data efficiency, but rather about transparency and explainability. And here we also are going to improve on those. Though the two use cases that I mentioned are to somehow extreme situations. No, in one case there is the automotive sector. There is an issue of data efficiency because the predictions are very hard to make. In the other case, there is data is enough, but there is an issue of explainability. So somehow there are two kind of extreme scenarios and you can think of others lying in between, like the health sector, for example, is characterized by, let's say, more data than the financial, in particularly heterogeneous source of data, but it is also regulated, but not as much as the financial field. So it's somehow close to finance, but not for certain aspects, and close to automotive for others. And you can think of many other use cases that can feel in between. So this is what I wanted to say, but I very welcome discussion as these, I believe, are very hot topics on which there is not much research. Actually, there's very little research and development. So it will be very important in the European context to work on this field. Thank you.
Thank you, Paolo, for this very good introduction into what are future plans around hybrid AI. It was Tommaso who presented current results, but you are looking into the future, what is going to happen. There is a potential audience of 225 people who are registered for the meeting. You are still sharing your screen. Oh, not anymore. Who registered for this session. So it is a big audience. And I can imagine that maybe some people are shy in such a large audience, but I do not yet see questions in the chat window. If you have questions, please put them there and I will forward them to the speakers. While you are doing so, I had one question for you, Paolo. Because we are now discussing hybrid AI as a means to make AI more trustworthy. And I noticed that while Tommaso was addressing it in a way to make the AI better, I can imagine that especially in the financial sector, but maybe also in the automotive sector, which are regulated domains, you could also use world knowledge models to restrict the behavior of the system. So it is a kind of a normative envelope that you are imposing on your system. Hard rules, like you can do anything within the limits of these rules, but you shall not operate out of bounds. Do you expect that this will become an important part of hybrid AI? Or do you think that using world knowledge will be mainly used to improve the existing operation of the accuracy of AI systems?
Yes.
What is your opinion about these two uses?
That is a very good and difficult question, Frick. Thanks for asking. Indeed, there are two ways in which the knowledge can be used, no? Using the language of, let's say, graphical models, or let's say causal, if you wish, the probabilistic expert systems that were in place in the 90s, to which we are somehow going back. There are two ways to implement this knowledge. One is to improve AI, no? And that is, let's say, for a fixed structure of causations or of correlation, fixed links between the different variables or nodes in the network. So for a fixed relation, we can learn from data better with hybrid AI, with expert knowledge, which we can encode into Bayesian a priori structures, for example. But there is a second way, that is exactly what you mentioned, to enforce rules into the structure, no? That is to use the data to learn between different structures and work with the structure that is most likely, or with the structure that is most supported a priori. Okay, this is a way to, as you said, to embed the rules, not just to improve AI, the machine learning, but to force machine learning within a certain subspace. So it can do both. I hope I answered.
Yeah.
May I comment on this, Freek?
Yes,
I think
please.
it's a very interesting discussion, and I totally agree with Paolo. Although I would like to add that the concept can also be flipped on its head up to a certain point. What I mean is that it has also very often been a prerogative of, let's say, sub-symbolic interpretation of rules to be implemented in a system where they become, if we think of behavior, they become very hard boundaries, but it is which the system cannot, has to operate within, right? That and the tendency normally of designers is to make these boundaries sometimes taking a pessimistic approach, more restrictive than they should actually be. But it is known that in certain situations, sometimes one has to prioritize over these boundaries, right? And hybrid AI can actually, we have seen it actually also at TNO, I believe, in some research done in the Helmond unit, where hybrid AI can actually sometimes be used to prioritize between boundaries. For example, even in the automotive domain, when one might have the, let's say, the temptation to add every individual code of conduct or rule of the road as a hard boundary, when one realizes that sometimes some boundaries, some rules have to be broken. And then the question is, perhaps the insight that I think people are discovering is that maybe, let's say, hybrid AI can lead to a good prioritization between which boundaries to break. So it's interesting how there is not a clear-cut answer, but you can really sometimes also even flip the question on its head at a certain point. Yeah.
That's a very interesting observation, because people have already noted that if you would convert law or regulations into computer executable code, there will inevitably be contradictory situations, and you would definitely need prioritization mechanisms to find your way out of that. Yeah. There is a question being formulated in from the audience from Norbert Jartroch. Very good to have you on board again, Norbert. I know your interest in this area, and you have formulated a very interesting question, and it is very well formulated. So I will read it literally. Norbert is writing, I understand that your approach to hybrid intelligence is about how to enrich data-driven AI by epistemic knowledge generation. Do you consider the other way around in your thinking as well? And if so, how? Because this would be to support knowledge generation by targeted reflective data reasoning, thus more sustainable, while innovative intelligence can be reached by combining human intelligence with algorithmic intelligence. for instance, to reduce the retarding effect of human loss aversion in decision making. So what Norbert is saying, could it be the case that you could also use data-driven AI and insights that you get from it to also improve the human understanding of the world? So yeah, maybe starting with you, Tommaso, what would be your thoughts on that, to use hybrid AI the other way around, so to speak?
I have to be honest and say that indeed, in my presentation, we trickled down from, let's say, symbolically charged or semantically charged concepts, and we try to apply them into the execution of sub-symbolic models, like I hope was clear from my presentation. The question, if I try to summarize it, is basically, can you actually also use data to generate concepts in a sense? I think actually quite some work, I believe Paolo also mentioned, that has been done in causality reasoning, right? When we basically try to see if the data can explain, it can not only be used to predict a model, which again, it's maybe very rich, but not semantically rich. Instead can be used to explain why certain events have happened. I think I mentioned before how in our projects Snow we can think about how environmental context can affect the actions that can be performed by the robot. A part, although on which I'm not, let's say, the most capable person to speak of. One of the functionalities that I mentioned was self-assessment, and part of it is also causality reasoning, where some of my colleagues are trying to explore basically the incoming performance of some actions performed by the robot and try to justify, for example, why a very low performance is achieved. So if you are in a room, as I said before, and you use your camera and you expect a certain performance, but this performance is very low, they have been studying causality assessment, trying to basically identify, okay, what is wrong with this room? Why does my camera not work correctly? And as I said, I'm not, let's say, an expert enough to go into this in detail, but indeed, I think such approaches do exist. But maybe they are a bit more recent, perhaps. Maybe they're not as immediate.
Yeah. Okay. Yeah. So then we're also looking into the future again, and maybe it could be a potential topic in the Tiger project. Paolo, what would be your idea for that?
I think so, and I think it fits very well with the idea of explainability as well, no? Because in the end, explainability or interpretability mean exactly what was in the closely to what was in the question. That is, converting the data-driven conclusions into something that is explainable, no? Into some potential causations, the most plausible causations based on the data. That is what explainability is doing, no? If you have 1,000 possible explanatory variables of a phenomena, explainable AI tell you which are the ones that explain the largest part of the variation in the response, no? Essentially, so it is a way to, in fact, to infer what you were asking from the data. Okay, and of course. Here comes, clearly my vision as a statistician. I didn't say in the beginning that I'm a professor of statistics, so this soul sometime come to me, and in this case, it tells me that we also need to test. Once we identify which are the most explainable variables, we should implement a statistical test to say why we use 8 of them and not 9 and not 10 or not 11. Now that is quite crucial. It is the role of statistics there.
Yeah. Okay. So you definitely see room for this yes. approach, and it is already being contemplated indeed for topics like causality detection. Yeah. And I think that is a very interesting a topic to arrive at, because then you are actually arriving at something that we also call co-learning. That means the machine learns from data that is provided by the humans, but the other way around, the human end user also learns from the machine. And if all is going well, they are entering a virtuous circle where the machine becomes better at understanding the data that is provided by the human, but also the other way around, that human behavior improves, becomes better, more well informed, because it is supported by machine intelligence.
Yeah, this, if I may, Frick, this you made an extremely important point. That is the point of endogeneity, because especially in in human behaviors, the data is also generated by the humans. So we build models based on data that can suggest causalities, but the data itself is generated by us. So there's a little bit of endogeneity here, no? It's not a natural experiment in which data is generated objectively from the outside world and we observe the consequences. Here, both the data and the hypothesis, let's say, are generated by humans. So that is a challenge.
Yeah. Norbert is also commenting in the chat that he's saying that research into the world climate is also an example of this, where you start with the data reasoning, and by looking at it, and this will lead you to formulate hypotheses just because relations have been identified by a data-driven approach. Yeah,
yes, that is a another important, very important example.
Yeah.
Because there, indeed, you have to build scenarios in the in the climate change, for example, topic. Data do not exist really. We can build probabilistic scenarios for the future, so, which again are generated by us.
Yeah, definitely. I have not seen additional questions coming up in the chat, and as I said at the beginning of this session, Dr. Christian Müller of DFKI had not yet arrived, and well, something has gone wrong because he is not joining the session. So probably something has been working out differently than anticipated. So that means that it has been these two contributions, but still I'm quite happy with it, because the first contribution showed some results in actually applying hybrid AI. And then the second presentation was really looking forward into what you could do with hybrid AI in a much more methodological way, and also in some different domains. So I think that nicely puts between brackets the topic of hybrid AI. Where are we now? And what are the plans to continue from here? And we had a very brief discussion right now on the potential meaning and importance of hybrid AI for better human-machine teaming in the future. That sounded a little bit like a conclusion. I would like to invite you both to also add, well, maybe one or two afterthoughts in a concluding way, looking back on what we've discussed, and also looking at the questions that were asked. What would be your conclusion when we talk about the topic of hybrid AI in relation to trustworthy AI?
Should I?
Yeah. Go on, Thomas. Yeah.
I would like to finish with a big why statement, but I will just maybe repeat what I already said previously. I really believe that, and I think it's evident that hybrid AI is going to arise organically when dealing with complex systems, and it is bound to increase trustworthiness due to a better understanding and a more relatable sharing of knowledge and information. Of course, I indicated at the start of my presentation what are the challenges, what we think at least in TNO there are the challenges, and moving away from, let's say, the current AI and moving towards more future AI with more complex systems, more diverse spheres of application. We are bound, I believe, to engage more and more with hybrid AI and push also the limit of what can be done and what constitutes hybrid AI further to enable better and better capabilities.
Okay, that is a very positively formulated conclusion. Really looking forward. Paolo, what would be your take on this?
Yes, my take is that we do need, I mean, it's clear that hybrid AI can bring important contributions and value, not only to improve machine learning and AI, but also to build them in a way that is consistent with our thoughts and beliefs. No, but I believe that to achieve this goal, an important effort should be undertaken in terms of standardization, particularly as far as trustworthy indicators are concerned. Because often we talk about principles, no, fairness, and anti-discrimination, robustness, and so on, but we have not yet a common standard to measure them, and we do not have thresholds, for example, that say, above this number is fair, below that number is not fair. So this, I believe, is something that should be done in the near future, particularly in Europe, to achieve the goal of improving the AI. Yeah.
And I think the key trustworthiness indicators that are proposed could form a basis for this. So that's a very good, that was a very good idea. And I really hope that we will be able to elaborate on them. Yeah. Okay. Well, I think that is very good to conclude with, that there's really a very good future for the application of hybrid AI, and it plays a number of roles, and it can definitely play a very good role in the context of trustworthiness, and that is a specific way that the European Commission really likes to pay a lot of attention to. So the topic is here to stay, and I think that in future editions of the EBDVF, we will be able to report on any progress made in this field, because I think it will only grow bigger. I would like to thank the two speakers for their contributions. I would like the audience for staying with us at the end of this day, and your heads must already be full with lots of information. Maybe I see a number of you again in sessions later this week, and otherwise we will see each other in other conferences, hybrid conferences, physical conferences, whatever. So thanks again. And I think this concludes our session on the role of hybrid AI in relation to trustworthy AI. Thanks again, and see you later.
Thank you.
Okay. Bye-bye.